Hello everyone. In this video, I'll be talking about BJT as an amplifier in CE configuration. Before we talk about the amplifier in CE configuration, let's know the basics of BJT. BJT means bipolar junction transistor, what we simply call as transistor. So BJT is a semiconductor device. That is, it is made up of P and N type semiconductor materials, which is being used in all the electronic circuits as an amplifier. Before transistor, vacuum tubes were used for the amplification process, which were of very huge in size, and they used to produce very huge amount of heat. In order to overcome these problems, BJT is being introduced, and it is made up of semiconductor material, and now it is being used as an amplifier in almost all the electronic circuits. So when we talk about BJT, we just try to know the terminals of a BJT. So for a BJT, we see three terminals: emitter, base, and the collector. So the next point is, what is amplifier? Amplifier is nothing but a device which can increase the strength of a weak signal, is called as an amplifier. So if you take a remote control and increase the volume of your TV, then the action that is being done there with the help of a remote control is nothing but amplification. And the remote control is now acting like the TV is now acting like an amplifier. Okay, so amplifier is a device which will increase the strength of a weak signal. So now what is meant by amplification? So generally amplification is nothing but the process of raising the strength of a weak signal is called as amplification. When we talk about amplification, we generally insist on a point called as faithful amplification. What is the difference between amplification and faithful amplification is, in faithful amplification, we raise the strength of a weak signal without any change in its original shape. That is, the shape will also be reproduced at the output in addition to the increase in the strength of the signal. So when we talk about amplification with respect to a transistor, it is obvious that, or it is generalized that we talk about faithful amplification only, not amplification. We consider faithful amplification is being done with the help of the transistor. Okay. Next is BJT, how it is acting as an amplifier in CE configuration. The first point to be noted regarding an amplifier is, when you want a BJT to be used as an amplifier, the connections for the particular BJT should be such that the input circuit of that particular transistor should be forward biased, and the output circuit of that particular transistor should be reverse biased. When these both conditions are met, then the transistor will act as an amplifier, or the transistor will show an amplification action. Or simply we can say that when a transistor is connected in such a way that the input circuit is forward biased and the output circuit is reverse biased, then the transistor is said to be in active region. So when a transistor is in active region, it acts as an amplifier. So in order for a transistor to act as an amplifier, we generally use CE configuration. Not only for the amplifier, in almost all the electronic circuits, we see CE configuration only. Why CE configuration is most widely used, though there are the other two types of configurations available. The other two types are common base configuration, common collector configuration. Even though common base and common collector configurations are available, but still 90% of the electronic circuits are made up of common emitter configuration only, because of the following reasons. Because the first main point is, for a CE configuration, we see moderately low input impedance. That is, it will be in the range of 1 to 5 kilo ohms range. Whereas when we talk about the second point, it will have moderately high output impedance. The output impedance will be in the range of some 50 kilo ohms. So because of this point, CE configuration is commonly used. And the other points favoring the CE configuration are, CE configuration will have high current gain, and it will have very high voltage and power gain, and the phase differences, that is nothing but the difference between the input and the output signals phase, will be 180 degrees out of phase. That is, input and output signals are exactly 180 degrees out of phase. So because of these basic reasons, generally CE configuration is most commonly used or most widely used as an amplifier. Okay, so in this circuit also, I have considered CE configuration only. So CE configuration is nothing but emitter is taken common for both input and as well as the output. So here the input terminal is base, output terminal is collector, and the common terminal is emitter. The applied voltage is between the base and the emitter. That is, the input signal what we apply will apply between the base and the emitter. The output that we want to collect, we collect at the collector and the emitter terminal, that is here. Okay, so when you connect a transistor in this fashion, you can observe a voltage VBE in the input circuit and a voltage VCE is there at the output circuit. And the input current is IB, which is flowing through the base terminal, and the output current is IC, which is flowing through the collector terminal. So when we talk about the circuit, when an input signal Vs is applied at the input circuit, that is between the base and the emitter, when you apply an input signal Vs, it will change the value of VBE. Because of the applied input signal Vs, VBE will change. As VBE is changing, IB will also change. As the value of IB is changing, consequently the value of IE will change, because we know a value called as IE is equal to IB plus IC. This everybody know, that is IE is equal to IB plus IC. So when IB is changing, automatically IE will change. Because of the change in the IE, there will be a change in the voltage drop across the load resistor. So this change in the load resistor will be collected at the output in an amplified fashion. Okay, a small change in the input current will show, or a small change in the voltage at the small change in the voltage in the input circuit will change a huge difference in the voltage at the output terminal. So this transistor action can be explained by taking some simple terms, like if you want to observe whether the transistor is acting like an amplifier or not, simply consider a load resistor RL which is of 5 kilo ohms is to be connected across the input terminal. And also we assumed that, or else as it is a CE configuration circuit, the output impedance will be high. So it is of 5 kilo ohms. So the input impedance should be considered low. That is, I have taken here a value of 1 kilo ohm. So 1 kilo ohm is the input impedance and 5 kilo ohms is the load resistance. So what we will do now in this experiment is, we will just try to calculate the value of V0, that is the output voltage which is being developed across the load resistor because of the change in the applied voltage. For that to happen, first we have to find out the value of IB. So when we talk about IB is nothing but input current, which is nothing but Vs by R1 or Ri. Vs here is nothing but, simply we consider a value of 2, the input signal Vs, kindly consider it as 20 into 10 power minus 3. So if you want to calculate the value of IB, simply take the value of 20 into 10 power minus 3 divided by, we already considered the value of Ri as 1 kilo ohm, that is 1 into 10 power 3. It gives you a value of, this is minus, so this gives a value of 20 micro amperes. So 20 into 10 power minus 6 is the value of base current IB. And the next point to be noted here is the value of IC. What will be the value of IC? So we already know that beta, if you want to calculate the value of IC, just you remember the value of beta. Beta will be equal to delta IC by delta IB. This everybody know, right? So from this you can calculate the value of IC. IC will be equal to beta into IB, right? So if you want to calculate the value of IC, you simply multiply beta into IB. As it is a CE configuration, as I already said that it will have high beta value. So consider beta as 100. So if you consider beta as 100, IC is equal to 100 into 2 microamperes. Already we got IB as 20 microamperes. In the first expression, we got IB is equal to 20 microamperes. So if you take IC is equal to 100 into 20 into 10 power minus 6, you will get a value of IC is equal to 2 milliamperes. So 2 milliamperes is the value of IC. So from the calculations or from the values what we have chosen, we obtained the value of IB to be 20 microamperes and we obtained the value of IC as, we obtained the value of IC as 2 milliamperes. I will write here IB is equal to 20 microamperes IC is equal to 2 milliamperes. Okay. Next is we need to calculate the value of V naught. V naught is nothing but the output voltage. So output voltage V naught can be written as, according to Ohm's law, we know that V is equal to IR. I here is nothing but at the output side the current is nothing but IC, right? And resistance is nothing but the load resistance, that is RL. So what we can write is V naught is equal to IC into RL. We already got the value of IC. We got the value of IC to be 2 milliamperes and we got the value of RL. RL is equal to 5 kilo ohms. RL is equal to 5 kilo ohms, right? So 5 kilo ohms into 20 milliamperes will give a value of V naught is equal to, V naught will be now equal to 10 volts. So here if you observe the applied input signal Vs is nothing but, we have considered a value of Vs to be 20 into 10 power minus 3. So this is a very small value when you compare it with the output voltage. So the input voltage Vs is 20 into 10 power minus 3 volts is the input signal and the obtained output signal V naught at the output side is equal to 10 volts. That is, the output signal has got increased up to 500 times. So if you if you calculate the gain factor, output by input, if you do the value of output by input, so 10 divided by 20 into 10 power minus 3, if you calculate, you will get a value of 500. That is, the voltage amplification factor is 500. That is, the input what you have given is amplified 500 times at the output side. So from this example, you can conclude that a transistor can act as an amplifier. So here in this circuit, we have given an input signal of 20 milliamperes and obtain an output of 20 millivolts and obtain a voltage of 10 volts, which is almost 500 times that of the input signal. So from this we can conclude that a transistor can act as an amplifier. As we are using CE configuration, so we can say that BJT is acting as an amplifier in CE configuration. So likewise, you can explain BJT as an amplifier in CB and CC configuration also. But for CE configuration, there are various favoring points like high output impedance, low input impedance, high current and voltage power gains. So all these factors are fetching points for CE configuration. That is why in majority of the cases we consider CE configuration when you want a BJT to act as an amplifier. So with this, I'll conclude, and I hope you got to know how a transistor is acting as an amplifier. Thank you.